Hello and welcome to our first assignment. In this assignment, we will be using Arduino to take temperature measurements and change the color of an LED based on those measurements. Specifically, we will take 10 temperature measurements, calculate the averages of measurements, and compare the average to a preset threshold. If the mean is above, we will turn the LED to red, and if the mean is below, we will turn the LED to blue. Let's start with the software. Create a new sketch. We will always begin by including libraries and defining variables. Libraries are collections of helpful functions that we can use. So if you include the math library, we can use functions like calculating square roots. Next, let's define some variables which can help store helpful information. There are several types of variables, and the most common are int for integers, float for numbers with decimals, and string for text. Since we are taking multiple trials and each trial has 10 readings, let's make 2 integer variables to keep track. Since we are using an RGB LED capable of changing color, we need to indicate which Arduino pins we will connect to the red, green, and blue pins. In our case, we will specify pins 9 through 11. Finally, we need to set a threshold that we will compare our mean to. Let's make this a float, so we make this variable have decimals like 30.0. Next, we will define some custom functions to get values like temperature readings from the thermistor, calculate the mean, and get the standard deviation. Functions are written by first specifying the type of variable the function outputs, the name of the function, and the type of input the function takes. Inside the function, we can perform calculations and modifications to the input and return our desired output. Before we move on, let's explore how a for loop works. So a for loop is a section of code that will repeat a specified number of times. We create these loops in the following format, creating an integer and assigning a value to start with, specifying a condition to check, such as if the integer is less than a certain value. So if this is false, then the loop will continue to run. Finally, we have the increment and decrement expression, which increases or decreases the starting variable across trials. Once the specifying condition is met, the for loop is end. In this example, we start the integer at 0, and we add 1 to it every time the code loops. So when I finally reaches or is higher than 10, the loop will end. Next, we move on to the setup code. This is what runs once the program is started. We will want to initialize pins, telling the Arduino what is plugged in where, and specifying the baud rate, which is the speed at which the Arduino communicates with the computer. We will tell the Arduino which pins the thermistor and LEDs are plugged into, and use the serial.println function with a string input to print out that the setup is completed and the data collection can begin. We will be able to see this text when we open the serial monitor later. In the main loop, any code we put here will continue to run repeatedly. As a quick overview, we will create an array or a list of float variables to store the temperature measurements. We will also have a variable for the current measurement. Between trials, we will increase the value of the count variable and print out the count number as a trial number. We will then use this for loop to take a temperature measurement and add this measurement to the list we made earlier. To indicate that measurements are being taken, we will also flash the LED green every time a measurement is taken. This for loop will repeat as many times as it takes for the variable j, which goes to 0, to become equal to or greater than n, which is specified was 10. Since the value of j increases every time the for loop repeats, it will take 10 loops to end the for loop, perfect for 10 measurements. After the loop, we will print out that the trial has ended along with the trial count. We will now calculate the mean and standard deviation of the data, so we will use the functions we made earlier with inputs of the list of data points, and the number of data points. We'll print these two values out. We now use an if-else statement, which checks if this condition is true and runs the section if it is true, and if the condition is not true, we'll run the code section in the else statement instead. Since we are checking if the mean is above the threshold in the in statement, we will change the LED to red if this is true. If this is not true, we have the LED turn to blue in the else statement. And that's it for the code. For the hardware, we have 2 main components to connect to the Arduino, a temperature sensor and an RGB LED. To make things easier, we'll use a breadboard so we connect wires to the Arduino and sensors without soldering. Let's begin by powering the breadboard. So we will connect a wire from the 5-volt pin of the Arduino to the positive red bus line of the breadboard. So from here to the red bus line. We also need to ground the circuit, so you connect a wire from the ground pin of the Arduino to the negative bus line of the breadboard. After we do that, we can start connecting the LED. So if you notice on LED, one of the pins is longer than others, and this is the ground pin. So you need to keep that in mind as you place it on the board. Why don't you place the ground pin so the longer end is facing outwards like this. Once you place it inside the breadboard, you can go really anywhere. As long as it's on this half of the breadboard, you can place it in. Now, we also need to have resistors between the LED pins and the Arduino board. So let's place resistors on the non-ground pins. So as you can see here. And then we know that this one is the longest ground pin, so we will not be placing resistors on that. Skip one, place a resistor there. And the next one, another resistor here. Make sure that's bridging the gap between the breadboard. And finally, for that one, we will also be grounding the ground pin. So from the negative bus line onto the pin we skipped over for the resistors. Okay. Next, we now need to connect the wires from the breadboard to the Arduino for the LEDs. So we will be using more wires. Let's start with the red pin. So the red's going to pin 11. So let's see, from pin number 11, here we go, 11. And we're gonna go over and find the red lane there, okay. Next up we have the green pin. So we will be using pin number 10 on the Arduino, and we'll be coming over to, we'll be skipping the ground wire and coming to the next one. Okay, and after that we have the blue wire. So we go from pin 9 to, again, just the last one here. And that's it. So the LED is now connected, and we can now connect the temperature sensor. So it functions as a resistor, so the order doesn't really matter. So we can just place it like this, just anywhere you want, as long as the legs are in two separate lanes. And of course, we need to power the sensor. So let's connect a power wire from the sensor to the positive bus line. So from here to here. So that way we can make a circuit through this. Before we connect it back to ground, we will also putting a resistor in between so we can have current flow through it. Make sure to put the two legs of the resistor, one in a separate lane and then the other in the same lane, sharing with the temperature sensor. After that, we can connect our ground pin from the resistor there to the negative bus lane. Okay. And to read the signals, we'll be using an analog input pin. In this example, we'll be using pin A0, so all the way over here. And we'll be coming over to this lane that has the photo or the temperature sensor flag here. And after that, that is our entire circuit. To connect to your computer, next step, we will be using a cable to plug into here, the type B cable. Other than that, that is it for the hardware. Next, we will upload our code. Connect your Arduino board to your computer with the provided USB type B cable. Verify your code has no errors with the checkbox button, and upload the code with the error button. Since the code is uploaded, you can go to the Tools menu and open the serial monitor to see the printed text outputs. You should see the trial number, measurements, means, and standard deviations. And on your circuit, your LED should pulse green once for each measurement and turn either red or blue after. That's it for the hardware and software portion of this lab. Thank you.